participants. I'm really happy you're here. Yeah, our now we are going to talk about the program which is called Pajek, and this is a program specially created for analysis and visualization of large networks. And I do hope that you will like this program as much as I do, and will try to do something by your hands. Okay, now let's have a brief introduction. I already introduced myself as the head of the laboratory. Also, I wanted to say that I am a sociologist and candidate of sciences in sociology. So my basic knowledge is not computer science or some advanced mathematical basement. So, of course, in sociology, we do have a lot of programs for analysis as well. But I just want to kind of explain explain my path to the field of social network analysis. I started moving to this field during the preparation of my thesis, which was devoted to the so-called network approach in sociology. And I was really lucky to publish it afterwards when I graduated from, when I defended my PhD. And actually, you can find this thesis and also the book in internet, or you can also write me and I will send you the version of this book. And this work was devoted to the description of theory and methodology of social network analysis, and also comparison of social network analysis, like from formalist approach with so-called relational sociology, and also with actor network theory. So it was the work which allowed me to kind of structure the field, and at least to come up with some basic terminology and basic understanding of what is network analysis is. And I think that it was really an input to the Russian scientific space, because there are many cases when we use some kind of network metaphors, but this is not going in compliance with other theories and methodologies. So I think that it's really important to start going deeper to network analysis, also from the theoretical point of view. And I advise those of you who are interested in network analysis at least to look, probably not in the book, but also I have an article which is shown here. It's also in Russian. So I think it deserves reading as well. But today, we are not going to talk about theoretical background and historical development of social network analysis, but I would like to share some results of the projects that we had with Professor Vladimir Batagel, which were devoted to the development of social network analysis. And I would like to show you some results that we got using Pajek and making such an advanced network analysis and analyzing the field where we all are included. So it's kind of reflection of the field, like what's going on in the field. And here you can see some of the titles of these publications. And I think you can also look inside if you're interested in social network analysis, and you can find some most central authors or journals, or understand how the field is structured in sense of topics and so on. But it will be a little bit later. Before this, we will talk about the program, and we will look at some operations and so on. So Pajek is a spider the translation of Pajek is a spider, and this is a program which is developed in Slovenia. And in Slovenian, spider would be Pajek, like pauk in Russian. So that's why we have this very nice creature here in the slide, right? And so this is the program which was originally created for the analysis and visualization of very large networks, which can have some thousands or even millions of vertices or nodes. And all the versions of Pajek are freely available, and they are totally non-commercial. So you can download the new package of the updated version of Pajek program from its official website, and the link is here. And basically, you can install it very fast, as I told you in the break. So there are two options how you can download it, and this is according to the properties of your computer. So you have 32 bits and 64. And here you have this green Pajek, you see, which is actually just a regular Pajek that you should download and install. So you basically click on Install Shield here, and then it will be automatically downloaded to your computer, and then you basically just press the buttons, and then it is installed at your computer. Probably the valuable thing will be if you will remember to which folder you installed the program, because then it will be possible to put something in the folders so that Pajek can use it. I will tell about it later. So this is how to download the Pajek. I didn't tell in words about the creators of Pajek program. So these are Vladimir Batagel, who is our professor, whom we already introduced to you, and also Professor Andrei Marvar, who is the former PhD student of Vladimir Batagel, and now also a professor in the University of Ljubljana, Faculty of Social Sciences. And this is a program which is being developed for all this time. And when the colleagues find some inconsistencies or bugs, or they just want to add some new features to Pajek, they always do it. And so you can always install the newest version of Pajek. So we will have our materials for today's seminar in the page of GitHub, and I gave you two links here. So now I think I will do the following. I will just send you the link to the chat, and you will be able, you will be able to follow it. Sorry, I think. Yeah, I will tell you about installation of Pajek on Mac just a little bit further. Probably you will not be able to do it. Sorry, you will be able to do it, but probably not at the session, probably later, because it will just require some extra some extra things from you. But let's go to this page. I will demonstrate my screen, and so sorry, this is not it. Yeah, so this is the wiki page of our summer school. I mean our workshop in this summer school. And you have something here. So this is for your usage. Please keep this link, and then you will be able to come back to it and to look how to make some procedures. And also the presentation, for example, is stored here. So it will stay with you. And we have the link, which is called Get Started, how to install Pajek on your computer. So you can just come here, and there are some instructions about Windows, but also for Mac OS, you should just follow these instructions by this link, and you will find some PDF file, which will just actually just 2 pages how to install it. And so I think you can basically do it really quite fast, but probably not so easy as Windows users. And also there are some useful sources on this page. So of course, Pajek website page, let's open it. I think I just noticed that on my slide, I have, it is written that the newest version is from 2018. So it just means that I used the same picture. But so you see that this is from July 1st. And also you can find a lot of useful information here on this website. So for example, you see like some minor bugs fixed. And so this is the newest version of Pajek. And so this is just the trace of what was changed. Then you will find some hints on Pajek, also running Pajek on Mac. So for those of you who has Macs. And then there will be also introduction to Pajek in different languages. You can also find Russian videos, which were recorded by me during the seminars in our laboratory. And also you can just go deeper to these links and just look what is here. So you can find a lot of very useful information. Then another very useful thing is the Pajek manual. This is the tutorial of how to work with Pajek. And this is just 115 pages and very useful. And I just advise you to, if you are going to work with Pajek, I just advise you to read it through from first to 115 page, and just to, so there you will find all the description of all the procedures that we have in Pajek. So actually you can just go by it and look inside Pajek and kind of get involved into the topic. Then, of course, a very important book, which can be needed for you if you're going to work with Pajek, but also if you're going to go deeper to social network analysis, is this book written by our colleagues, Andrei Marvar, Vladimir Vitagel, and also their colleague, Walter Denoy. And this is already the 3rd version of exploratory social network analysis with Pajek, and we have it in our library. But also you can find some, I think, previous versions of these books, and also, yeah, you can, if you need some parts of these books, you can also write us. And the great thing is that this is not only the tutorial of how to work with Pajek, but this is the explanation of how to work with social network analysis in general, exploratory social network analysis. And at first you would have some, let's say, more theoretical and more methodological chapter. I mean, in each chapter you will have at first more methodological oriented material, and then it will be shown how exactly to make it in Pajek. So the operations are written, like what you are doing in what steps, and so also a lot of examples are provided, so that you can basically just go through and you can just repeat what is there, and you will succeed a lot, I'm sure. And also there is a article, quite old one, but anyway, this is the article devoted to the description of analysis and visualization of large networks with program package Pajek. So this was a kind of description of the program in a journal, and so also the colleagues are going to through the main operations, main methods that they have that they have installed into Pajek, and so on. So this is not a large one, but I think this is very useful. And also here we have some supplementary programs which you can install also, but they could be needed for your further work, but not yet, not now. So basically, you would need some text editor. So I recommend TextPad. This is really nice, but probably you have something else, and it also will work out if you have just another text editor. Okay, so now, so let's go back to presentation. Yeah, unfortunately, I can't say too much about installing Mac with Apple different programs because I'm a user of Windows, and so that's why I never did it. And so I think, but I'm sure you can find a lot of instructions how to do it. Okay, so now let's go to and yeah, what I wanted to say is that my first I first time met with Pajek when I've been to the University of Ljubljana at the scholarship in 2017. And I just remember that when I was going, let's go back to Pajek. When I was going there, I just, of course, searched what the colleagues are doing, and I realized that they developed their own program, and I was not sure if I will ever manage to work in it. And I worked pretty hard, and I really went through all these tutorials and the books several times, and so I had a lot of practice. And now I think I understand Pajek quite well, and I really like it, and that's why I would like to share the knowledge about this program, because it's really a fantastic one. And so that's why today I'm talking about Pajek. And personally, I use it in my research, and I will show you some results. So the plan for today is a bit large, I would say, but okay, we will see how we will manage. And we have two main things to do. First one is to overview main capabilities of Pajek. And I would like to show you some basic operations in Pajek and also some advanced operations. And at least for basic operations, I propose us to do something all together so that you will get the knowledge of knowledge and skills of how to operate in Pajek, with how to create network in Pajek, how to open the network, how to calculate some basic metrics and some statistics for networks, and also how to visualize network, because it's impossible to think about social network analysis without the visualization of networks, because it's a kind of main thing in network analysis. And then talking about advanced operations, we would look at different types of networks. And so these are not regular networks, and Pajek allows us to work with these non-regular types of networks, such as two-mode networks, acyclic networks, temporal networks. And as already Marian told you, also there is a special algorithms. There are special algorithms developed for block modeling in Pajek. I would not tell you too much about block modeling because it's really requires a whole seminar. I'll just show you some basic things where to find these procedures. But there are some recorded lectures already. So if you are interested in it, if you are interested to continue your evaluation of your studying of Pajek, which we just so successfully started in the previous lecture, so you can also find the way how to do it via Pajek. And then I would like to show the results of our analysis. And as I said, this analysis is devoted to the development of social network field, social network analysis field. And I think it can be interesting for you as probably new people to the field. So it's just interesting to kind of understand what is happening here and what is the state of the art. But so this is from the substantial point of view. So it's interesting, and you will get some knowledge of how the field is organized. But at the same time, I think it's important to say that we've done all the analysis in Pajek, and you can see how powerful it is, and which amount of information you can actually analyze with this program. Okay, so but at first we would go back to some basic definitions because it's important. Probably some of you haven't heard about network analysis too much before you came to this school. So let's just step back a little bit and discuss what is network. So network is basically network is composed of two sets, so which are graph and data. So graph is the representation of network, and this representation is composed of nodes. Also, they are called vertices, and links or lines, which represent the connections between the units of analysis. So basically, these are units and the relations between these units. We will not we will not go into too much details about the meaning of relations and the types of the nodes. So just for now, it's important to say that we have nodes and we have links, and the nodes are connected by links. And these links or lines, they can be either directed. Yeah, then we have this small arrow on the line, like here from A to D, and they also can be undirected. And in this, so this is from D to C. And we call this lines in a different way. So the directed link will be, or line will be arc, and undirected will be called edge. So let's remember these terms because they would be important for us just on the next slide. And what is important, so we have graph for graph of nodes connected by links, and also we have some extra data, so the attributes of the nodes, attributes of the links, and so in combinations, this graph, just simple structure with this additional attributes, they compose network. And there are, of course, different types of networks, and they go from different kind of network data. So as you already observed, they can be directed and undirected links. And in this case, the types of network can be the following. So we can have network with directional, non-directional, or mixed links. So these are different kinds of network already. Then we can have one or several types of links, like friendship, and also borrowing materials, and also borrowing money between the same people. And then we will have so-called networks with multiple relations, or multiplex networks, networks with several types of links. And then we can have one or several types of nodes, yeah, not links. And then the network types would be two-mode networks, like bimodal. They also called affiliation networks or bimodal networks. And also they can be, if we have, yeah, I didn't tell. If we have also several types of links, also we can have multi-level networks, which are networks with several types of links and nodes. So in combination, if we have different types of links and nodes, then we can call this network multi-level. And then also we can observe the network in static and also in dynamic, and then we would have either static or temporal dynamic networks. And also they can be some unique links and like genealogical links, and this will cause in specialized networks such as pgraph, PetriNet, which are used in genealogy and biology. But don't worry and don't be frightened too much. Today we are going to talk only about two types of networks, which are just simple networks, let's say, which can be directed or undirected or mixed, and also so-called two-mode networks. And this is a little bit more advanced topic, and we will come to it a little bit later. But at first, let's look at the, we are going to look at the main capabilities of Pajek. And it's important how we insert the data into Pajek, right? Because if you, you can, you need something to start working, right? You need some network. So this is the same picture as we now just discussed, and you can, there are different formats how we can write down the information about the nodes and links. And one way how we can do it is just to say that our network is composed of set of nodes and links. So you see here we have all the vertices here, and then we have all the arcs, and then we have all the edges written, like from which vertex we have relations to which vertex. And they all compose a network. And in Pajek, we will just simply, what we do actually, we just open the text part or some text editor. And at first we need to specify that we have 12 vertices. Yeah, we already counted how many we have. And we will put the asterisk, and then we will write the word vertices, and we will put 12. Then we just need to make a column with the numbering of the vertices from 1 to 12. So as much nodes as we have, we just make the one column. And then we just write the titles of our nodes in this double brackets. No, not brackets, quotes, in these double quotes. And then what you do, you actually make an asterisk and you write arcs. And then you just write down from which node to which node you have a link. So, but you don't write that you have a link from A to B, but you will write just that you have a link from 1 to 2, because these are the numbers of these nodes. And then, as you see here, we have opposite arcs. So then we will need to also write that we have a relation from 2 to 1. And so on. You are writing all the information about arcs, but then also we have edges. So these are the links which doesn't have direction. So then we will just simply need to write once, that we have a relations from B to E, which would be from 2 to 5. And that's it. You don't need to write back that from 5 to B, 5 to 2. So it's already enough. So the main things are asterisks, vertices, amount of nodes that you have, numbering of all the nodes from 1 to the last number. So it should be the same as here, as 12. And there should not be any lost numbers. So it should be just, from 1, 2, 3, 4, 5. So you cannot write 1, 3, 5, and so on. And also you don't use 0 here. So just remember about it. And then asterisks and arcs and asterisks and edges. So this is how you do it, and then you just save it and open it in Pajek, and we will do it a little bit later. But I also need to tell you that there are other formats, such as when we describe each node with the neighbors which it has. So we have node A, and this is connected to B, D, and F. And in this case, if these are the arcs, it is written here. So this is a node arc for A. And you just then you will use the another writing. You will just write asterisk and then arc list or edge list. And then you will just include all the neighbors of your node. So for node number 1, you have 2, 4, 5. For 2, you have 1 and 6, and so on. So you just describe your network in this way. And again, so this is the full description of your network. Another type of data format would be a matrix, so-called adjacency matrix, where you can have all the nodes by columns and rows. And you just have zeros and ones if there is a link from this node to another node. And so, for example, here you have these parallel arcs. So that's why from C to G, you will find 2. Yeah, so there are 2 links from going from C to G. And then you will just use your vertices 12 and the list of the vertices as previous, but then you will write matrix after asterisk and just insert this matrix only the zeros and ones without the columns the columns and rows with the titles of your nodes, only the values. And actually, in adjacency matrix, adjacency matrix can be binary. So they can be either it can be that the relation exists or doesn't exist. And then you just put 0 and 1. But also it can be a weighted matrix, and you can also put the strengths of links between Jill and Jim, for example. And then also Pajek will read such matrix, and the values of lines will be different. Actually, yes, we should just go back here. For this type of network data, you can also write here after arcs. You can also add the third column, which will mean the value of links between 1 and 2. So it can be 2 and 1, it can be 10, and so on. So you just make a third column. It's impossible to make it here in arc list because you see we have just connections between the neighbors. So if you would like your network to be weighted, so if you have weights in your links, so then you should definitely choose either first variant or the matrix variant. However, for large networks, matrix format is not the best option because you see we have a lot of zeros, and this character takes the capacity of the memory of the computer, and then it will be just much more difficult to analyze such networks because it's just weight much more than, for example, the network created with the first option. Okay, and then as I told you at the beginning, also besides the graph, we also have the additional information in our networks, and these attributes can be they can be presented in different way according to the data type of data according to their type of data. So here we just have a table of with all the files for the data which is called wolf monkey data, and these are the data of observations of connections between monkeys, and they were probably cleaning themselves, cleaning each other, helping each other. And the researchers were just writing how many times they somehow communicated. So you see what we have here. So this is the network called inter.net. So net is the extension for network. And then we see this asterisk vertices 2. It means that we have 20 vertices. And then we have the titles, the labels of our nodes. So you see we have males and females. And then we have asterisks and edges, which mean that we actually are not it was not possible to differentiate between in sense of direction. And so it means that these are just undirected relations of monkeys. And it means that from first to second monkey, from MO1, MO to MO2, there were two kind of cases of communication. And then from first to third, 10, and so on. And then we can also have some extra data about our monkeys. We can have their gender, for example, their age, and this would be different types of data. So as for the gender, this is the data which is nominal. And it means that the node belongs to some cluster or some group. So this is called clustering or partition. So it means that your network can be separated into several groups. And in this case, we use the extension clue, so which is clustering, partition, and we basically call it partition. So the network is split into two groups, but also it can be, they can be more groups. But if we have numeric data about our nodes, such as the property of age, so then this would be a vector. So we can have a different value for each of our vertices. Here you see that there are some monkeys are of the same age, but in general, it could happen that they would be of a different age. And we will write this information in the format which is called vector, and it will have the extension vec. Also, we have a so-called permutation, which is the ordering of nodes, so that we can reorder our network according to, I don't know, some of our ideas or some of our analysis. And then this would be a permutation, and the extension would be this per. And how we write down this data, we just open a text part again, and we just write again asterisks and vertices and the number of them. And then we just write the we just put the column of either partition or vector and save it. And so this would be this extra information that we can attach to our network. So Pajek, probably you, if you already downloaded it and opened it, you already saw that there are different windows in Pajek. And this is the program where you should press the buttons, which I really like. So at first, you will have the window with networks, and this is where you put the files with the extension net. Then you have these partitions, and here you open and also save or operate with the files with partitions, with clusterings. Also, then you have vectors, permutations, and then you have cluster and hierarchy, which are actually the windows with which you work when you are doing block modeling. So now we are not going to talk about it. This is a little bit more advanced thing. So now, now we will just we will finish the presentation for now, and we will go to our materials in GitHub. Yeah, let me demonstrate it. So now we already observed this get started link, but now we will go to workshop materials with the basic procedures in Pajek. So at first we can look, actually I already kind of explained you how we make these different files, but just let's repeat it once again. You can make it as a homework and repeat this. So the idea is that you repeat this picture, and actually how you do it, yeah, you just write the number of vertices, then you list all the nodes, then you look at the arcs which we have, and they are of different color, and they have this asterisks or the arrows, and then you just write edges. And actually what you do next is just save file. So let me open it in another window. So let's do like this. So what you do, you just open your text part, any text editor, and then you write this information. You can make this character and write something about like what is this file about, so that this after percentages, this part will not be written by Pajek. So it will start reading it only from the start. And basically what you do, you just go to File, Save As, and you can say that this would be network number 1, for example. net1. And then what is important is to say that you need to have an extension net. And for this, please, I pay you attention to this part right now. So it's really important that you make this double quotations. And in this case, your file will be saved in that format that you would like to have. So this is actually a nice hint for other projects and other work that you have. So let's save it. And then I'm just going to my folder. And so this is the file, text file that I have, right? And you can also download it from the page. So you just press on it. And then when it is opened, you just go to Save As, сохранить как. And as I told you, you are saving it in the folder where you work. And then let's do the following thing. Let's open Pajek. We were waiting for it for some time already. And let's look. Oh no. Probably I will need to download the new one. Just a second. Hopefully. Okay. Okay. So then I will do the same thing that you did right now. I will install a new version of Pajek. It was opened at my computer because I was doing some analysis before. And just before our session, I closed it because I didn't want to mix different Pajeks and to somehow change my results in my project. So, but it should be very fast. Probably meanwhile, you do have some questions. We can discuss something. Are you okay? Are you alive?
Can you please show again the format of the file to download it?
Yes, sure. You mean
of the textual file? Is just TXT document or which one?
Yes, this is just a TXT document. Just let me go through Pajek and it will be installing and yeah, finish. So it's actually done. So now I will open it. Yeah. So basically what you do, you open your, it's not that one. Just a second. I didn't do what I advised for you. So you should remember what is the path to your Pajek, because then you will need to find it. Sorry. I'll just open it from here. But you can also move the. What's going on? Huh. Probably I should try once again. Yeah, a lot of things happens. I was preparing and I had Pajek on my computer and now it became expired. Okay, now we will go to this local Pajeks. So this is from today and it should work. Yeah, finally, I'm really happy I have it. Okay, let's look inside. And Dmitry was asking a question. Yeah, you just open your TextPad or any text editor, like new one. And what you do is just making this asterisk, and then you are writing vertices, and you just need to write how many vertices you have, 20, for example. And then you would need to write 1, 2, 3, 4, and so on until it is 5. It is there 20. And then you also need to insert the titles, the labels of your nodes, like A, B, and so on. I advise you to use this double quotes, but however, it's not necessary for if your labels consist of one character or one word. So then Pajek will read it correctly. But I'm just, in any case, I'm doing it like this. And then when you write down all the information, you just go to File and Save As, and then you see that it is the type of the file is txt, but if you put the dot and you write net, so then, and you will make this double quotes, so then your file will be saved in the proper format that Pajek will read. So basically we did it, and now we opened our Pajek, and automatically, as it is brand new, it's opened the local folder where it is installed, and I'll just draw your attention that there are some useful things that you can see. So for example, these macros, they can be used for drawing. It's impossible to see it, okay, but so there are some macros which you can use for example, drawing some types of networks, which are already written here. And you can also read the macro by your own, like the set of procedures which should be implemented and to analyze some data. Okay, but we will go to my folder where I have my this net1, and let's let's see, I have this net1, and this is written, it is file net. Yeah, and I'm just save this. No, I should open it. It is here. Yeah, I see this net1. And then what is happening? I have my so-called child window. This is the report window, which shows what was done and what is the result of this. So you see, here it is written that the network was read. So this is the title of the network. And so then it is writing down everything which is written after this percentages character, as you saw. And it would be written that 19 lines read, and so how much time was spent, because it's important, of course, not for such small networks, but as Pajek is dealing with huge networks, then it is really important to know how much time was spent. And then we will, what we can do, actually, this is pretty small network, and I would advise us just the basic thing that we should do is just to go to draw network and just to visualize it. And here, the separate window for visualization will be opened, and you can use different layouts here so that the network will be automatically reordered, the nodes and links will be reordered somehow. You can use different algorithms for this, but this is not, this is a toy network, so it's not really so interesting to look at it, but I'm just showing you some basic things, right? And we will open another network soon. So I think that now we can close it, and I will show you some options in visualization on that another network. I lost myself a little bit. So we are here, and I just advise you to take this to save, for example, these files or create them by your own and just to check with my files. And then you can also make some vector, which will be the numerical information on your nodes, and also some partition. And then here we have some operations for basic visualization, and this is actually what we just did, draw network. And there are some options, but let's just use another network to make it a little bit more interesting. But yeah, okay, let's just go here to using prepared network files. So my idea was that first thing, how you can create your network. You can do it by your hand. You can, if it is a small network, you can write it down by yourself. If it is a huge network. There are also some converters to create networks in Pajek, and then, but also you can, for example, take a matrix from Excel file, let's say. But before this, you will just list all your vertices by yourself. So this would be how you are creating your networks by your hands. But then also some networks already exist. For example, you will work with some data, like to learn how to make some operations in Pajek. You will just use some data which is already prepared. Or you can use also some converters, such as POST. There are some programs which are called text to Pajek or VOS to Pajek, and you can convert other types of data into Pajek. Or you can work in Python or R, and then to save your files as PY files or net files, which will be read in Pajek. So now we have already prepared network files, and it is funny that this is exactly the same network that Marian was talking about. So this is the same student data set, and we have different networks of students answering the questions with whom, from whom they would borrow the teaching materials, whom they would select to inform about some important news in school. Or with whom they will go, whom would they like to invite to their birthday party. So I think birthday party is pretty nice, and let's look at this network. So let's open it. Again, you see we have the same structure. Also here on the right, we have these 3 columns of numbers. What is this? These are their coordinates. And this is a very nice feature of Pajek, because you can kind of fix your node in some certain point on the picture, and then you will save your file. And then when you open it, the place of node will be automatically adjusted. So you will have your nodes exactly at the same places where you left them, which is really important, because sometimes some pictures can be really if you have, like, let's say 200 nodes, so then the picture can be too crowded, and you are working a lot just to make it a little bit more visible, but then you close it in some program, and then you will have to make it again. For example, you need to make some small changes in your pictures. And what Pajek allows you is to fix these coordinates, and this is really nice. And why 3 columns? Because we can fix the coordinates in 2D format and also 3D format. So Pajek can make pictures in 3D format, like some biological networks or some, I don't know, medicine networks. It can be important just kind of to see genes from different points of view to move them, and that's why you can even may use this 3rd column. And also you see here we have this ellipse box. So what it is, from the very beginning we can say that some nodes should be shown as ellipses and some as box. So this would be also the distinction between G and M, so between women and men, and they will be shown by different shapes. And also you can actually insert many more information into your files. So it's not necessary that you make it in Pajek. You can just write it from the very beginning, including colors and yeah, the titles, the labels, the font of labels, and so on. So a lot of information, and I will also show you the link where you can get this information about this different characteristics that you can insert into your files. And then let's open this file of birthday invitations. And so I already saved it. You can open it and save as well. And don't forget to write net. And then I have it here. What we basically do, the first thing that we do when we got when we get the network, we go here to this information and we just press here OK. In the majority of cases, you just press OK. But of course, you can also customize somehow. But what we need now is just to look at the basic information on our vertices. So this would be number of vertices 32. Then we have total number of lines, and it would be written either we have arcs or edges, and we have 79 arcs. Will we have loops? Loops are the cases when the node is like going to itself. And then if we have multiple lines, it would be also stated here. We don't have multiple lines here. And also density will be calculated, which is the proportion of the links that we have in our network to the links that can exist in our network. Yeah, if all the links will exist. So you see that we have this density here, and also average degree. This is actually the average degree is the average amount of links that the node has in network. Yeah, what we have, we also have here the partition, the distinction between the nodes. And let's open it as well. So you will learn how to open the partition. You should open it as a separate file. Yeah, here you just should download raw file or save it, save as, and so on. I think you should open it as raw. Yes, here. And then you can save it as, and then you should write clue at the end, and don't forget again to use this double quotes. And I already downloaded it, and I have it in my folder. And I just go to partition and go to this yellow folder and just open the file. And again, we opened it, and the first thing that we can do is just to go to info and to look what we have, right? Just press OK. And then this is the case that some of you might have. You might lose your window of reporting window. And if so, you just go to info, child windows, report window, and show. And then it appears. And what we see is the distinction of our network into two groups. So we have one group, the first group with 22 nodes, and second group with 10 nodes. And now we can visualize it in a little bit more different way and a little bit more interesting way. If we will go to draw and we will make network plus first partition, so then you see that our nodes will be colored according to partition that we have. So we have two partitions, and that's why we will have two colors. And if we just press on the node, we will move one node. But if we will just go somewhere close to the node, so you see that we will move all these yellow ones, yeah, or green ones. Yeah, and then you can work with some visualization and then save it. But I think we should do it a little bit later, because basically what we can do now, we will learn how to yeah, we will learn how to get the information about the most central nodes, how to find important nodes. So we will go to, so it would not be a partition, yeah, right? Because this is not the splitting of the network into parts. Yeah, we would like to see some very important nodes, the nodes which have the largest numbers of inputs, input degrees. So degree is actually the number of links which the node has. If the network is directed, then we have two versions of degree. So it can be in degree or out degree, yeah, because these are different types of relations. And in accordance with this, we can count the most central people who has the largest amount of people pointing at them, people choosing them, and also output degree will mean that these are the people who are choosing as many people as possible, for example. So we can go to create network, create vector, centrality, degree, and then we will go to input. Let's look what we will have. And while we make it, we will get the message with the calculated network input degree centralization. So this is the metric centralization and metric of centralization, and this is the metric describing the network, how centralized the network is. And centrality is another term, is another metric which is used for specific actors, specific vertices. Yeah, so don't mix up centralization and centrality. So centralization is for network and centrality is for nodes. Unfortunately, we don't have much time to talk a lot about this differentiation. I just want to put your attention to some important things. And you see, at the same time, we got in this window, we got the information with input degree of our network. So of N2, so this is N2, you see, it is here number 2, and we understand that this belongs to this network, because in Pajek we can have a lot of vectors counted and a lot of networks. You see, we have here 2 already. And it's always nice that we can return to some network or just to merge some information from different vectors to one new vector and so on. Okay, now let's just continue. So we want to see what are the central actors in our students group. And for this, we will press here to info again. But here we would not just leave 0. We will make a plus, and we will tell that we would like to see, like, let's say 10 most central people. And then automatically what Pajek does, it also writes the information about the values, the distribution of values in our network. So here we have we have 32 nodes, and then we have 2 nodes which has value 5, 6 nodes value 4, and 7 nodes with value 3. So that's why when we look a little bit up, we see these largest values, highest values. And so these 2 people, this women 23 and women 8, would be the most central students. And then we would have this group of actually 6 people having 4, yeah, like it is written here. And then basically we have 7 people with 3, but Pajek just listed the first 2 who are alphabetically going first, because I asked to provide me the list of 10 most central nodes. And now what we can do, actually we can make our picture even more looking much better. We can go to draw and we can go to network plus first vector and first partition and first vector. So now look what we are doing. We have this graph, yeah, we have this structure, and then we put partition, yeah, we make different colors of our nodes, and then we will also add the information about the value of vector so that each node will also have different value, 5, 4, 3, or less. And then we will have such a picture. So this picture already looks even much better because we can actually see who are the central actors. Can we mix two networks? Yes. Thank you very much for this question. I will move to it. Yes, yes. This is exactly what Pajek is done for, among other things. I will just briefly show you how to save this picture because you might want to do it. And you just, first of all, you can go to options and you can play with different colors, sizes, lines, and so on. So this is not the topic right now, even though it is very interesting. And then you can go to export and you should export your picture either in JPEG format. And then if you do it, let's look how it will look like. Just a second. I need to write the folder. So this would be pick one. And if we look at it, you will see something very similar to what we had in Pajek, right? But if we will use this another format, SVG format, which is really a very advanced way of making visualizations, you will get some other picture. And let me show it to you right now. So then you will open it and you will see something else, something like this. So you see this is different. You also have these mutual links because actually we have arcs and not edges, but Pajek, just for the matter of simplification, shows you it in a different way. So if it is the mutual relation, so then you will just have one link with two arrows, but not like here, right? And to adjust this, to adjust this picture, you would need to go to here to options. And also here you will find a lot of options that you can use to make your picture looking really good. I should say that probably from this simple picture, it's not seen so well, but actually Pajek is a very nice tool for visualization, and the colleagues were winning a lot of competitions in the field of visualization of networks because they actually have a lot of opportunities here in Pajek. You can even look at some, you can make triangles, houses, men, women out of your nodes. And yeah, you can work quite, so you can create quite an interesting picture. I would just simply, in this page, I will just simply go back to here to the list of your materials, and you will have the link which is called hints for visualization. And here you will find same thing that I was telling you, so that you can write down some information in the file, and like there are even, for example, interior color, border width, and so on. So you can adjust a lot of things for your nodes and links, and you can then save it as configuration, and you can use it further for your other visualization in your analysis. Now we should come back to the workshop materials. I will just briefly go through all these concepts that I actually made some notes for you here. So this is how we look at the global properties of networks. Yeah, as we already seen, we know how to look at the size, density, average degree, strengths of ties. Now our nodes, our network is not weighted, so we don't have different line weights, but we can actually check it. we should go here to network info line values, and it would be written that all values of lines are equal to 1. Otherwise, you will have some distribution, and you will know how, for example, how to cut your network. You would like to, for example, leave only the strong links, and you would choose some threshold, and you will decide that above this threshold, all the links we preserve, but what is less, then we will just leave them from our network. Yeah, then I also have some, this is about network centralization, and this is about important nodes and centrality and line cut. Also, I inserted here sortativity and homophily and network transitivity, which is a little bit more advanced. I mean, probably not advanced, but this is something further. So it's not just the basic, these are not the basic characteristics. But I think you can do it by yourself. You can just follow my notes here and just do it with your networks as a homework, for example. And now, as we had this question, but please let me look what we have. How to choose threshold? It is governed by some laws. No, actually, you should just look at the distribution, and then you should think about you will see the shares of links with these values, and you just should have some expert knowledge and understanding of your network which you study. And also you should think about creating a network which will be a kind of doable, analyzable. So if you want, for example, to visualize a network, so then you should just keep in mind that it should be at least less than 1,000 of nodes, because then it will be really, everything will be mixed up. So usually you just look and you just try different times, and then you come up to some decision. So as we had this question about different networks, like can we work with different networks? Can we mix two networks? So this is exactly about the two-mode network analysis. And I wanted to say something to you at first, like on a theoretical level, and then show you how to work with such networks. So two-mode networks are networks where you have two sets of nodes which are not connected inside the set, and the connection can exist only between the sets. So they are also called affiliation networks. So it's also a kind of clue for you, because we can have, for example, people working in some organizations, students studying in some university. So there would not be any relations between students and no relations between universities, but there would be a relation between student and university person and organization. And Pajek is also very nice in sense of allowing this type of networks. And what you basically do, here on the slide, you have some very short description of such a network, but you have this asterisk, then it is written vertices, then you would have the total number of vertices that you have in your network, and then extra value, extra character appears, which actually this number means how many nodes are included into the first set. So this helps Pajek to split the network into two nodes, help to understand which nodes belongs to first set and which nodes belong to the second. And of course, at first you should write down the nodes belonging to the first set, and only then those who belong to second. So you should not mix them, because then Pajek will never understand it. And then you just write down the edges and so on, and the links can exist only between first and third, first and fourth, and so on, and second and third, second and fourth. And you cannot make a link between first and second, and then Pajek will be telling you that you are not making a correct thing. And these are for temporal networks, but let's just stay here for now and come back to our wiki page. And so here we will have a very famous data set, which is called Davis, and you can learn more about it. So these are the relations between women and I mean, these are women going to some events, and we have the relations only between these women and this event. So on this slide 19, we have 7 vertices, not 5. Let's check myself. No, so look, we have the total number of vertices is 5. Yeah, we have author 1, author 2, book 1, book 2, and article. And author 1 and 2 are authors and people. And then we have materials, publications. Yeah, probably you somehow didn't see. Yeah, and so the total number, and then only the second number means how many nodes we have in the first node. And so here, you see also I have some clues for you here for this two-mode network of Davis. So here we have 18 women. Yeah, from here 18 women are presented, and then 19 we have events are listed. Yeah, so in total we have 32 nodes. And basically what we can do, we can open this network also. And it is written how to open it. You should download this data. This would be the file with a lot of different data for Pajek, and you can actually practice with it. And you should choose the Davis net from there. Davis net would be looking like this. Let's look at it and practice a little bit more about the format. Yeah, you see, we will have each list. Yeah, so we will have for each woman, we will have the list of the events that she attends. And this is a very logical in this sense, right? Because we will just list the information which we have for each of the women. And then let's just open this Davis file in Pajek. It would be written that, yeah, it is red, 53 lines red. And then the first thing that I advise you to do, just go to info and look what you have in your network. And it would be written that this is two-mode network, and the number of vertices is 32. We have edges, and it would be written that this is two-mode network, and rows is the number of rows is 18, and the number of columns is 14. So Pajek kind of understand the network as the matrix where you have rows and columns. So, and it simply means that in your first set you have 18 nodes, and in the second you will have 14. And then some density is calculated. However, this is a density for two-mode network. And then average degree is also calculated. So how many links in general, on average, each node has. And what we can basically do, we can, of course, visualize it. Yeah, it has some interesting visualization like this automatically, but we can do something like this. But what we can do, we can split this network into two parts. And for this, we have in Pajek a separate algorithms. So you can go to two-mode network and make partition into two modes. And then you will have here this partition. Yeah, and it will be splitting your network into two parts. And then you already can I think, understand what we are going to do. We are going to draw with network with first partition, and then you will see the differentiation that we have our women and we have our events colored differently. Of course, we can calculate some vectors like centrality, and here, as we have kind of direction from rows to columns, yeah, in our matrix, yeah, we can, if we count inputs, input degree, so then we will look and see the women. No. No. Okay, then forget about it. I didn't tell you this. You should actually separate the partition, you should separate, you should split this vector according to partition, and then you will be able to see this top events and women. But I think let's not do it right now because it can take some time. And basically we can get the understanding of what are the main events and women right here. So we already have the understanding that we have main events number 7, 9, and 8, and we have 3 women who were the most active going to 8 events, Nora, Teresa, and Evelyn. But what is interesting with two-mode networks is that they can be quite easily, let's go here. Yeah, they can be quite easily multiplied by themselves. Okay, let's go back to Pajek. So actually, if the general approach to the analysis of two-mode networks, of course, there are some algorithms developed specially for two-mode networks, but the general approach is that out of these two-mode networks, you create one-mode network, and then you analyze this one-mode network. So based on this Davis data, what we can do, we can, so this is some, we can make one-mode network of events. How events are connected to each other according to the women who were going to them, because some women are going to some events and some women do not go to these events but go to other events. And also you can create a network of women, like how they are connected by going to the same events. So how events are connected and how the women are connected. And I will Yeah, exactly. Thank you very much for your comments here. Harani, thank you. What we can do is actually to deal with two different networks. So what we will need? We will need to transpose our network first, so that at first, now we have at first women and then we have events, but we will need to have a network of events and women. And what we do, we actually go to this two-mode network and we transpose two-mode network. And let's look at the info. We see that now at first we have rows and then we have columns. At first we have 18 and then we have 14 and then we have 18. So when what we can further do, we will choose this Davis net, original one, and we will choose this transposed one. And we will just go to these networks with multiple, in plural form. So meaning that in this window, we are dealing with 2 networks. And what we will do, we will just multiply our networks. So the networks will be multiplied. And the result will be a one-mode network. And we should say yes. And then we will have the network of 18 women. And we can even draw this network. Yeah, you see? What we can do, we can calculate, for example, the vector. we can calculate the vector of their centrality, and we will. Yeah, but let's first. I should look. So. Yeah, I didn't look at it like this. Yeah, you see, we have some. Here we have some arcs, which number of lines with value is 1, and then we have number of lines with value more than 1. And also we have loops because they are created automatically. We can remove them, and yeah, we don't have multiple lines. So now, if you will go to this network info line values, you will see that we have line values from 1 to 8. And we will be also able, for example, to cut some of the links in this network. And then what we can also do, I can show you that we can make some transformations of this network. So we can go to create new network, transform, and for example, we can remove the loops, yeah, because we usually don't need them for our analysis. And then we can go to create new network, transform, and also, for example, we can, I don't know what we can do. We could remove selected vertices, for example, but let's not do it right now. So we have this network, and we will calculate the centrality degree, but it would be weighted degree. So it means that if the link of the weight, so in the first approach, we just calculate how many links we have, yeah, how many relations the network has, or the node has. But in this weighted degree, we will also take into account the weight of the link. So this would be like the strongest. So if the node has less links than other node, but they are very strong, so then its weighted degree will be higher. And so we counted it, and now we can draw network plus first vector. It would be something like this. Automatically, I have some size of vertices. Yeah, we will make it after size. And so it will be something like this. And then we can make layout, and it would be, yeah, you see that pretty much everyone is connected to everyone. But let me show you also another option here. You can go to the lines of in network, and you can choose this different width. Yeah, so then the stronger lines will be shown, but let's make the size of arrows less so that it will not be so, yeah. And then we can go to also we can also make a grayscale, and then the values with the highest, I mean, the links with the highest values will be also marked in almost darker. But you see here, it's not really looking very good. What we can do, what we should do, we should go to network info, or network, create new network, transform, sort lines, and then we can go to line values. I think it would be ascending. And then if we, so another network will be created with sorted lines. And if you draw this, it should be looking better. So I'm just trying to give you some hints on the way. Okay, so I think you understood that it's possible to multiply networks. And actually, the whole this part of two-mode networks is working. I mean, there are different algorithms, so you can transpose. So two-mode to one-mode, but you should just look in the book or in manual, yeah, like explanations about all these algorithms. And then you can make some analysis of two-mode core, Actually, I especially wrote you here some, I told you that usually when we analyze the two-mode networks, we usually just create one mode network out of them, but I especially inserted here some ways of two-mode network analysis, like eigenvector approach. Also, there are two-mode coarse approach, but I just decided that it would be nice if you have at least something to practice. And then also we constructed the network of women, but also you can create the network of events. You just would need to change the order. So at first you will have your transpose network, and then you will have this Davis net original network, and then you will multiply, and it will be it will create this network of events, how they are related to each other. Yeah, there are some events which are very similar, and some events which are not. Okay, now you can look more precisely in the materials, and probably I will just take a few more minutes to tell you something that I wanted to tell. But it's important to say that Pajek also allows us working with so-called acyclic networks. These are the networks, these are the directed networks, like the networks of citations, when the later nodes are kind of cited by previous nodes, but the previous nodes can be cited by later nodes. So, for example, in bibliometric analysis, we have such networks, and with this function, a cyclic network, we can actually make a lot of analysis, like a so-called main path analysis. I will just show you my results of this analysis. Also, there are so-called temporal networks. So these are the networks when the node and link can exist in some certain point of time. And there are different approaches how to make this temporal network. So we can create a kind of set of networks for each period, like here shown on the slide. But also we can insert the information about all the vertices, and then we will just write down exactly at which periods the link existed. And this is possible also in Pajek. So you see here we have this temporal network algorithm. Also, you can work with multiple relations network. So if you have, as I told you, that you had different relations like friendship, borrowing materials, borrowing money, living together, or something like this, and then you can kind of look at different levels. So you can extract the network only of friendship, and then another network will be only of borrowing materials, and you can kind of compare and so on. So also Pajek allows you to do it, and also signed networks, which are very special thing in network analysis, very well developing right now. So these are the networks of positive and negative relations. And also it is possible to work in Pajek with these kind of networks, but personally I didn't. But also Pajek can read the genealogical files, and you can even analyze your own genealogy using Pajek. So then I didn't tell you what we have here up, but this would be just as kind of groups of algorithms that we can implement to networks, to partition or partitions, to vector or vectors, and so on. And also very useful thing is operations, when you can operate with two objects, like you can take a network and then partition and then extract subnetwork according to partition. So for example, you would like to extract only boys out of our students network, and you will just extract a subnetwork. Yeah, now I have different, so you see that my chosen network and partition are not the same. So that's why it is saying that it will not do it. But yeah, here you just need to, that it should be 32 and 32, and then you go to operations, network with partition, extract subnetwork, and you should say just one, for example, and then you will get the network of your 18 women. But of course, yeah, what I wanted to say, of course, I don't know. But our events will be kind of lost. Okay, this is just for some kind of comments. And I wanted to tell you that this two-mode network analysis and multiplication of networks and working with a cyclic network actually allows you to work with bibliometric, to make bibliometric network analysis. So this is the application of mathematical and statistical methods to study books, periodicals, publications, authors, journals, and so on. And my idea was just to show you, to make a brief introduction to this topic, but I will give you it to study by your own. So we personally, me and Vladimir Batagel, we are working in the field of bibliometric network analysis, and this is, let's say, my sphere of expertise. And the project that we were doing in the development of social network analysis field was done using the tools of bibliometric network analysis. And why it is important, because actually Anushka Ferligoy today mentioned that the field developed, the field has quite an interesting history of development. So it started in social sciences, then it moved to different other sciences. And we used this approach to look like how the field is developed. And just to tell you that our data was more than 70,000 records. And then we analyzed 1 million, almost 1,300,000 of works. And out of this, so we used it in Pajek, and we had also 93,000 of authors, 32,000 of keywords, and 8,000 of journals. And we were multiplying these networks, and we were analyzing, counting some special indices for them. And Pajek really went really well, and we got the results, and the results are published in the journals. And I just invite you to look at them, and just to just to understand how the field is organized. But I would just probably stay at some final conclusions, because I think it's important to say that actually now the field has grown significantly, and the number of papers is growing every year, and it doubles every 3 years, as we found. So can you imagine how important now to study social network analysis? And the disciplines which were involved in social network analysis are social sciences, and then, as we said today, network science. But what we found from 2010, we have the group of people studying animal social network analysis who use the same methodology and very advanced models of network analysis. And so this is really can be applied to different spheres. Of course, it doesn't mean that it's not presented in other fields, and the most cited works still belong to the social sciences, and also other cited, highly cited works are from socials, from physicists and computer scientists. And if you think to study Pajek, there are ways how to do it at our master's program. So at MASNA, Vladimir Batagel by himself is teaching 2 courses. One course is Introduction to Network Analysis, and then we have the Advanced Network Analysis Methods, which is a compulsory course, elective. The first is compulsory, and the second is elective, and you can go deep into network analysis as much as possible. So by this, I think I will finish my presentation. Sorry for making you stay in here for 10 more minutes. Let me answer to some questions. Is there a separate paper on SNA history to read? I would really advise you to read this book of Linton Freeman, the development of social network analysis. And this is Linton Freeman was one of the founding fathers of the field, and he's he really knew what he's writing about, and it's really nice and interesting. And you can also go to to my book, because I was trying to also get the information from different sources and also show the history of the development of this discipline. Okay, then we have another question of why should there be an each if the each weight is negative? Yeah, it's not a weight negative, it is the relation between the nodes which is negative, and it can be quite a large weight. So it's people can not like each other with certain with quite a high value. So it means that it's not the value is negative, but this is the kind of relation. Okay. So, dear listeners, we have 30 of you staying here. Great, thank you very much. So now I think we should stop. I will stop the showing, and also I will stop the recording.